Welcome to section 6.4. We are going to be talking about inverses today, and we're going to use the ideas that we did in section 6.3 to help us accomplish the inverses. Okay, so I'm going to start off with the basic idea at the top. In order to find the inverse, what you need to do is you need to switch x and y. So we're going to change the variables x and y. And then in order to find the inverse, we're going to solve our equation for y like we're used to doing. Now, the problem is once you resolve it for y, are you going to know if it was the original or the inverse? And so in order to keep those separate, we're going to write the inverse as f to the negative 1 of x. And we know that f of x is the same thing as y, and that negative 1 just tells us then that it's an inverse. Okay, so we're going to walk through a couple, and I'm going to start with column number 1, and we're just going to walk through a couple of these in order to be able to determine inverses. Okay, now the first one is the easiest of all of them. If I give you a set of points, the inverse is the switching of x and y. So this new inverse, which I'm going to say f inverse, is, and I'm going to write those brackets like they have, because it's signifying a set of points. And then my new inverse points are going to be switched. So -2, 5. So we switch the x and the y. 3, 4. 4, -6. And 3, -7. And then we're going to close those brackets. And so you can see that the inverse is just the points in opposite order. Okay? Now that's going to be a rare occurrence for us, but I want to at least get the idea that in that case you just switch x and y. For number 2, we're going to find the inverse given an equation, and here's the one where we're going to use more often. So in order to find the inverse, we're going to first start by switching x and y. So instead of y equals, it's going to be x equals 7y minus 4. What we're going to do then is we're going to get it back to say y equals. So to get the y by itself, I'm going to add 4. X plus 4 equals 7y. And I'm going to divide each quantity by 7. And I'm going to call it the inverse. So I'm going to say f inverse equals, let's see if I can make that clearer for you, because we want it to be f -1, right? So if I say f to the -1, f inverse of x equals, now that I know it's y equals, I'm going to say, okay, x over 7 plus 4 over 7. Okay, or you could say 1 over 7x if you want there too, but that's the general idea, where here is our inverse. Okay, we're going to do this again, okay, and the third one, you'll notice it has a square. Now I'm going to cross off f of x a second, and I'm going to put a y. This is going to help us classify our answer. And so we're not going to use this until we're ready to give our final answer. So keep that in mind. Now let's start. We switch x and y. So x equals 4y squared. And now we're going to solve. So first we divide by 4. So I have x divided by 4 equals y squared. To get rid of a squared, we square root, and we know that when we square root, we have a plus or a minus. Okay, now, as I look at this, I'm going to do a little bit of work first before I decide to write the inverse. The square root, if we remember back to chapter 5, we square root the top and we square root the bottom, and then we have this plus or minus. Well, the square root of 4 is 2. So I have plus or minus the square root of x all divided by 2. Now I'm ready to write my inverse because I solved for y. So my inverse is f inverse of x equals, and I want to go back now to this one. This says make x less than or equal to 0, which means I want the -1. So I don't want to say plus or minus, I just want the negatives. So I have the negative square root of x all divided by 2. And this is our inverse. So at the end is when we decide, do we want the positive or the negative based on what we've got. Okay? Last one, same type of idea. Let's do that again. I'm going to change this to a y. And now I'm going to switch x equals 1 over 36 y squared. To get rid of 1 over 36, I'm going to multiply by its reciprocal. So I'm going to multiply by 36 on both sides. So I have 36x equals y squared. And to get rid of a squared, we know we square root. And every time we square root, we get an answer that's a plus or a minus. Okay? So again, I'm going to simplify a little bit before I write my inverse. But I have y equals plus or minus. And like we did on the one before, we square root of the top and the bottom. We're going to square root the 36 and the x. So the square root of 36 and the square root of x. And the square root of 36 is just 6. And the square root of x I can't do anything with. And then we look at our domain and we say, hey, listen, we only want when x is greater than 0 or the positives. So I don't need the plus and the minus. I only want the positives. So I say f inverse equals the square root of 6x. Now I'm not going to put the plus sign in there because again it's positive right as it is right there. Okay, so that's the general idea of finding an inverse. The second part is slightly more difficult and it uses the idea of composites from 6.3. Now, if you want to verify, if they give you two functions, then the only way to prove that they're inverses is to do their composites, okay? So what we're going to do is we're going to find each composite and verify that we get an x out, and that's the important part. When you find their inverses, you have to get an x, okay? So here's what we do, and now it's a little harder with f and f inverse, but I'm going to show you the idea. We start with f on the outside, so f is 7, and we leave a spot where the x is, and then say minus 4. Inside of that is the inverse, so we put the inverse in there, 1/7 x plus 4/7. And now we're going to distribute. Well, 7 times 1/7 is just 1, so with an x, plus 7 times 4/7 is just 4, minus 4 that was at the end, and you'll notice the 4's cancel out, so you're left with x. That's a good thing. Okay? Now we're going to go the other way. This time we're going to start with the inverse. So I'm going to start with 1/7 times my x plus 4/7. And inside is going to go my f function. So 7x minus 4. And I distribute, well, 1/7 times 7 is x. 1/7 times negative 4 is negative 4/7. And then I've got this plus 4/7 at the end, and we know that those cancel out, so I'm left with x. Now, because these both get us a value of x, we know that yes, they are inverses because both composites equal x. Okay, now this again is the harder part, so let's try one more. I'm going to start, in order to verify their inverses, I'm going to do both composites. So I'm going to start with f, and the x is just the x, and then I raise it to the 4/5. And I'm going to put inside the inverse, which is x to the 5/4. Now, according to our exponent rules, we multiply those, and 5/4 times 4/5 is 20 over 20, which is just 1, so I get x. And I go the same way on the other side. I start with the inverse, which is x, so I put my parentheses, to the 5/4, and inside goes the original function f, which is x to the 4/5. I again multiply them and get 20 over 20, which is 1, so I just get x. So are these inverses? Yes. Now here's the thing to keep in mind. There will be times that one of them works and the other one doesn't. Unless both of the composites get you x, they're not inverses. So it has to be both pieces, and that's the important part. Okay? Last part is talking about graphing inverses, And so we're going to look at that. And I'm going to bring up our graphing calculator, but I want to put this function 1/4 x cubed plus 3 into our calculator. Okay, now I'm going to X out of this so we can actually look at our calculator when we do this. Sorry, we want this one. There we go. Okay, now I'm going to turn this on. Let's take a look at this. We want to go in our y equals, and we want to put 1/4, and whenever we do fractions, we should put them in parentheses. So 1/4 x, and to get the cubed, you can go to your math button and get the cubed, or you can just use your exponent key, which is this caret key, cubed, plus 3. Okay, and I'm going to graph this. Okay, so I can kind of see my graph. Now the point is we need to be able to put this on the calculator. So let's go to table, and I'm going to plot some of the points, and I'm going to get a couple of them on here. So let's take a look. -13 is not going to be something on my graph, so let's move it a little farther. Okay, so if I take my graph, and let's plot some points. I see the point -2, 1, which is right here. I see the point 0, 3, and I see the point 2, 5. And if I look back at my graph, I can tell that this kind of curved like this. Okay, so we want to show kind of that curved region. So here's my original function. Now, our goal is to graph the inverse and find the inverse. Okay, well, we know how to find an inverse. And you know what, I'm going to move this a second. We know how to find an inverse. We start by making this a y and switching x and y. So x equals 1/4 y cubed plus 3. So I'm going to start solving. I move my addition and subtraction first. So I get x minus 3 equals 1/4 y cubed. To get rid of the 1/4, I multiply both sides by 4. And I'm going to multiply all of this by 4. So let me see what I've got so far. Now I'm going to distribute this a minute. I have 4x minus 12 equals y cubed, because those canceled out. To get rid of a cube, we use a cube root. So I'm going to cube root this side, and I'm going to cube root this side. So my inverse, f to the -1, my inverse is the cube root of 4x minus 12. Okay, now if that's my inverse, they asked us to then now graph it. Okay, so I'm going to go back to my grapher. And in my y equals, let me get rid of this one a second, I'm going to cube root. So I'm going to go to my math function again, and let's cube root 4x minus 12. And close my parentheses. All right, if I go to my graph, take a look at what it looks like. Oh, kind of an S-type shape. And if I go to my table, I should be able to find some points. Now let's see if I can move this. I'm not getting great ones, but let's see what we can do. Now what I'm going to do is I'm going to change my color a minute so we can see the difference. I see the point 1, -2. I see the point 3, 0. And I see the point 5, 2, which 5, 2 is a little bit off, but let's fit. That's 4, 5, up 2 is like up here. And if I look at my curve, it goes something like this. Now the question is, as we make this, what do we notice? Well, it looks like it's turned sideways, but I want to relate it back to the points. In the blue graph, this first point here is -2, 1, where on my red graph, it's 1, -2. This blue point up here is 0, 3, and on my red graph it's 3, 0. Again, if we remember, the x and the y get switched. Okay? So in an inverse, the x and the y get switched. So let's talk about how this relates. The inverse of a function can be graphed by switching the x and the y values in points. Okay? When I talk about the domain of my blue function, my original, domain means x's, it's exactly the same as the y values in the red one, and y values are range. So it's the same thing as the range of my inverse. The same thing applies where if I talk about the y values of my original, or the range of my original, it's the same thing as the domain of my inverse. So that's just really kind of going back and saying the x and y axis. The one way to tell if a graph has an inverse without actually having to find it, if I just want to know does it have an inverse or not, the easiest way to tell is this horizontal line test. Now you know the vertical line test says if your graph touches this vertical line only once, then it's a function. Well, the same thing applies to horizontal line. If I make horizontal lines and it only touches my graph once, like it only touches at these specific points, then my function will have an inverse. So if you look at all of these horizontal lines, I'm only touching at those points on the graph. I'm only touching once. Then my function will have an inverse, and so we can actually solve it and find that this graph is the inverse. Okay? And so we'll talk more about this, but this is the general idea for section 6.4. We'll do a warm-up in class to talk more about how to find an inverse and how to verify. But I can tell you right now that this middle section is where people tend to lose the most points in this chapter, because I'm going to give you two equations, and the only way to verify is to do the composites. Okay? This is the only way to verify. And I can say this as many times as I want, and still some people don't get that. You cannot find or show that they're inverses any other way than by finding composites. So kind of keep that in mind. That's it for section 6.4. Thanks for watching.